All right, hello everyone. Our topic today is looking at chapter 5.5. So we're looking at continuous random variables and a little introduction to normal curves as well. So far we've talked about discrete random variables. So now we're moving on to the continuous. So first, all I'm doing is just reminding you of some tools that we have to describe data. So we know to always make a picture, visualize our data, plot data. We know how to make a histogram, a stem plot, box plot, etc., all in our graphing calculator. We know that we're looking for some sort of pattern, some sort of shape to our data, so we can describe the shape. Is it skewed? Is it symmetric, etc.? We can talk about the center, right? We can call the center the mean, the median, the mode, and we can indicate how spread out our data is in relation to our center. Okay, we also can recognize any deviations, any outliers that really don't fit the rest of the data. So we can describe our center, again, many different ways, mean, median, mode, and our spread. So this could be our standard deviation, this could be the IQR, etc., and we have choices. So 5-number summary or mean and standard deviation. So sometimes the overall pattern of a large number of observations is so regular that we can really just describe it by a smooth curve. So this leads us into density curves. So a histogram is replaced with a smooth curve that describes the overall shape in an idealized way. Density curves have areas under the curves of exactly 1, which represents a proportion of data of 1, or 100% of the data. The area under the curve represents the proportion of data that would fall within that specific region. All right, so here all I've done is I'm showing you what we've typically looked at in the past, just this histogram, and all we're doing is we're smoothing out these irregularities by overlaying a curve. So when I draw it in, it would look kind of like this. So roughly like that. And all I'm doing is I'm smoothing out those irregularities and I'm just looking at it in this idealized way. So right here, now I'm looking at a density curve that has a strong skew to the right. So right here where it's pointing out, this is where the mean would be located. And we've always thought of our mean as the balance point, because really we have an equal amount of weight on both sides. Okay, my visual here is just meant to remind you of what happens when we have skew. So this visual right here, we see that it is pretty strongly skewed to the right. It's where that tail leads us. That's the direction in which it's skewed. So when it's skewed to the right, the mean is pulled closer towards that tail region, and the median is closer to where the concentration of data is. So here, let me remind you of that. When a distribution is skewed, the mean is pulled towards the tail end of the distribution. Okay, so now let me push up and we can focus on normal curves. So normal curves are a type of density curve. They are symmetric, they are bell-shaped density curves. They are completely described by the mean and the standard deviation. The mean determines the center of the distribution, and it's located at the center of symmetry. So right smack in the middle, that's our mean. The standard deviation determines the shape of the curve. It is the distance from the mean to the change of curvature, the inflection points on either side. The normal curve approaches but never touches the x-axis. Okay, so here, just to kind of unpack what it's saying in there, Here would be the mean and the median, right smack in the middle. They would be in the same location, and in fact, the mode would be there too. So I might as well add the mode. Right, that's where it's peaking. That's where our mode would be. Okay, these two notches here and here, they represent one standard deviation below the mean, and here is one standard deviation above the mean. So right about here and here. If I go up to my curve itself, right at one standard deviation below and one above, this is what it's talking about when it's calling them the change of curvature points. So right here would be the change of curvature or inflection points. Okay, and it just determines how steep or how squished down that curve will look, right? Is my curve going to look like this? Or is my curve going to look more like this? Okay, so now here, again, one more thing to note off to the side and just practice drawing it. If it's symmetric and bell-shaped, so if symmetric and bell-shaped, we know that the mean, the median, and the mode, they're all in the same position. Okay, so let's just sketch out a normal curve. So I can start off with my x-axis right here, and I'm going to overlay my normal curve. Pictures don't always show it, but there is a little gap between your normal curve and the x-axis. So it's meant to be an asymptote, right? That sort of boundary line that you approach, but you do not touch and you do not cross it. Okay, and then right smack in the middle is our mean. And then right about here and here, I'm going to make two little notches here and here. So these are really extreme values. This would be 3 standard deviations above the mean. I'm going to use my fancy notation right there, that lowercase sigma, standard deviation. And this is 3 standard deviations below the mean, just like that. So anything that's beyond those 2 cutoff points, so anything out in here or down in here, right, it's not that it's impossible, it would just be a really rare situation. So I can think about something like height. So if I go back to height, I think of average male height. Let's say that I say it's about 5'9". Okay, so down here could be someone who is maybe 4 foot tall, somewhere in that spread, 4 to 5 feet tall. And over here could be someone who is, you know, a professional basketball player who's 7 foot tall. Right, so I'm looking at those 2 extremes that would be out in the tails of this distribution. Okay, and then I'm just going to split it into thirds here and here. So this would be +1 standard deviation above, +2 above, -1, so that's below, and -2 below, just like that. So when I draw a normal curve, right, my mean is right smack in the middle, and then here I'm 3 above, and here I'm 3 below. All right, I'm just going to pause for a moment. Thank you.